Welcome to Phase 1, Lesson 4. Docker Compose. The app, not the container. So far you have run one container at a time. But one container is rarely an application. Today we level up. We describe the whole app in one file, and one command starts everything. A real app is many containers working together. A web server, a backend API, a database, a cache. Running them one by one with Docker run becomes chaos. You have to remember the right order. Is the database before the API? It depends on startup time. You have to wire them onto the same network by hand. Each one needs its own flags, ports, volumes, and environment variables. Picture this. You type Docker run for the database, with volume flags and port mappings. Then Docker run for the API, with its environment variables. Then Docker run for the web server, and you hope you got the network right. This does not scale. This is chaos. The insight is this. Stop describing containers individually, and instead describe the whole app. Its services, their relationships, their configuration, all in one file. One command starts everything. That file is docker-compose.yml, and the tool is Compose. Why is this a big deal for you? Because this is the exact same idea as GitOps and Kubernetes manifests later. Declare the desired state in a file, run one command, and the system converges. Compose is the training wheels version of a Kubernetes manifest. You are learning the philosophy in its easiest form. Let's build something that actually talks. A tiny web app with a Redis database. A visit counter. Every time you refresh the page, the count goes up. 3 files. app.py, the application. A Dockerfile, to build it. And docker-compose.yml, the star of the lesson. File 1, app.py. A tiny Flask application. It imports Flask and Redis. It connects to Redis using a host from the environment variable, Redis host. On every request to the root path, it increments the visits counter in Redis and returns a greeting showing your visitor number. File 2, the Dockerfile. It starts from Python 3.12 Slim, sets the working directory to /app, copies app.py into the image, installs Flask and Redis with pip, and runs Python app.py when the container starts. File 3, docker-compose.yml. The star of the lesson. It declares 2 services. Web, built from this directory, with port 5000 mapped, the environment variable Redis host set to Redis, and it depends on Redis. And Redis, the official Redis 7 Alpine image, with a persistent volume named Redis-data at /data. Let us zoom in on the environment variable, because this is the glue that connects everything. In Docker Compose, the web service sets Redis host to Redis. That value, Redis, is the name of the second service in the same Compose file. Inside the Docker network, services are reachable by their service name. So when app.py reads Redis host, it gets the string Redis and connects to the Redis container on port 6379, the default Redis port. The port is not even in the environment. It is hard-coded in the app as 6379. So the environment variable tells the app which host, and the app knows the port. This is how the 2 services find each other, without any IP addresses. Compose sets up the network, and the service name becomes the host name. Read it like a sentence. The app has 2 services. Web is built from this directory Dockerfile, listens on port 5000, gets an environment variable pointing at Redis, and should start after Redis. Redis is the official Redis image, and its data lives in a persistent volume. One file describes the whole application. The mental model. Containers find each other by name. The magic line is Redis host :Redis. Inside the Compose network, your app reaches the database simply by using the service name Redis as a host name. No IPs. No ports on your laptop. Nothing to look up. Here's the picture. Inside the Docker network, web, running app.py, talks to Redis at the hostname Redis, port 6379. Web publishes port 5000 to your laptop. Redis stores its data in the Redis-data volume. The application is connected without a single manual network configuration. The commands. Docker compose up-d, build and start everything in the background. This is the one command that replaces all your manual Docker run calls. Then the everyday commands. Docker compose ps shows the status of all services. Docker compose logs -f web shows live logs from one service. Docker compose down stops everything but keeps volumes. and docker-compose.yml stops everything and deletes volumes. Warning, that destroys data. Run up-d, open localhost port 5000 in your browser. Refresh a few times. The visitor count should climb. The app is talking to the database, and you did not wire up a single network by hand. You declared it, and the system converged. Here is the pro lesson. Depends_on Redis only means start Redis before web. It does not mean Redis is ready. Containers can start before they finish initializing. So web might connect before Redis is listening. The proper fix is a health check. Wait until Redis actually responds. Add a health check to Redis. Test with Redis-CLI ping. Interval 2 seconds. 10 retries. Then in web, change depends_on to a condition. Service healthy. Now Compose waits for the condition, not just the order. This started versus ready distinction is one of the most important in all of distributed systems. You will hit it again in Kubernetes probes. This is a lesson you will carry forever. Started does not mean ready. A service can be running as a process but still initializing. In production, Kubernetes uses the exact same idea with readiness and liveness probes. You are learning it now at the easiest possible level, so it is review later. Your exercise. Build the 3 files above and get the visitor counter working at localhost port 5000. Refresh the page, the count goes up. Then docker compose down, not -v, and docker compose up-d again. The count survives. Why? Because the volume persisted. You just demonstrated the data lesson from lesson 3 in a real app. The final part of the exercise. Add the healthcheck block to your compose file. Run docker compose up-d again. Confirm the app still works. And use docker compose exec redis-cli, get visits, to reach into the running database and read the counter directly. You are now operating a real multi-service application. Prove it. Question 1. How does web find the Redis container? No IPs, just a name. Because Compose creates a network and registers each service by name. The environment variable Redis host is set to the service name Redis, which resolves like a host name on that network. This is better than hard-coding IPs because names are stable. An IP can change when a container restarts, but the service name stays the same. Question 2. What is the difference between docker compose down and docker compose down-v? Docker compose down stops and removes the containers and networks, but keeps the volumes, so your data survives. Docker compose down-v also deletes the volumes. Warning, that destroys data. Use -v only when you intentionally want a clean slate. Question 3. Why is depends_on insufficient on its own, and what fixes it? Because depends_on only guarantees the order containers start, not that they are ready. Redis could be starting up while web already tries to connect. The fix is a health check that probes readiness, and a condition of service healthy in depends_on. Now Compose waits for the real readiness signal. Question 4. In one sentence, how is a docker-compose.yml file philosophically similar to what you will see in Kubernetes later? Both declare the desired state of an application in a declarative configuration file, and the system converges on that state without manual steps. Compose is simply the smaller, easier version of that same philosophy. Quick recap. One container is rarely an application. Compose describes the whole app, its services, relationships, and config in one file. Containers find each other by name on the Compose network. Docker Compose up starts everything. Depends on is start order, health checks are readiness. And the philosophy of declaring desired state in a file is exactly what Kubernetes does at scale. Lesson complete. Your containers are now talking to each other as a real application.